Okay guys, welcome back. So today we're going to talk about something new. I will start looking at or studying the most widely used database query language. I mean here the SQL, okay? SQL or SQL either is fine, okay? It stands for Structured Query Language. It's used for storing, managing data in a relational database management system, okay? And which the standard language for the relational database system in general. It enables us as a user to create, to read, to update, to delete a relational database, okay? And also tables in general. So all the relational database management system like SQL, MySQL, Postgres, Oracle, Microsoft Access, SQL Server, etc. use SQL as what? As their standard database language. That's why it's worth to study this one in our class. Okay? So if you want to follow me, this is chapter 3 of the textbook. Okay? So what's the plan of today's class? Of course, we cannot cover everything, but this is the plan of this chapter. It's gonna go over or give us like a survey of the base data manipulation language and data definition language features of SQL or SQL. Then after that, we're gonna show the transition from the relational algebra to the SQL. So starting looking at the way that how can we build, how can we write our SQL query. Then after that, start working with the real database. So starting today, I'm gonna assign, by the way, by the end of the day, I'm gonna send you email, or maybe tomorrow morning, send you email that require from you to start building or set up or preparing your computer to work with the Postgres database. Okay, so you can practice whatever we cover in the class, especially starting on the this chapter. Okay, so I will start with the overview or quick overview of the SQL query language in general. Then after that, starting looking at the way that how the SQL can be used in order to define data or different data definitions using the SQL. Then after that, go over the way the basic query structures of SQL query. Mainly, I'm going to mainly focus on the select statement. Then after that, go over a few, or let's say, additional basic operations, set operations. How can we handle the null values, aggregate functions? I'm not sure we're going to cover this one today or not. Then nested subqueries, and then after that, modification of the database in general. How can it be performed? Insertion, deletion, okay, or update to the database. Okay. Both of the American, let's say National Standard Institute, okay, with ANSI, and the International Standard Organization, ISO, adopted the SQL as a standard language for relational database, okay? And starting publishing specification for the SQL language, okay? So this is standard usually what is called SQL 1, then after that add some minor revisions and produce another SQL, and etc. So most vendors of the relational database management system have added features to the standard. So it looks like right now I'm going to teach you the standard, which is going to be SQL 92 features. Then after that, if you try to use whatever we apply in the class, might be required for me to do minor change, okay? For the basic operations, not, but maybe there's a case. For example, we say that we can do this operation using standard, but for example, Postgres, they have a different way in order to handle this one. So generally speaking, most vendors, the people that build the database management system, added features. So this is the feature, the standard, then they have something extra, okay? And use their own extensions for the language, creating a variety of delegates around this standard, okay? So since some parts of the counter standard are optional, not all the vendors, okay, provide the full set of features described in the standard. So sometimes you're going to see that when you say, we do have like specific standard, or this standard, SQL standard said, you can't do this operation, but there's no one implement this one, okay? So let's start with the first thing, the SQL parts. So SQL in general, with a query language, as you mentioned at the beginning of the class, I've said the SQL is defined as what? It stands for the structured query language, which used for storing, managing data in the relational database management system. So it allows us or enables the user to perform the following: to create, to read, to update, to delete database or relational database. Okay? SQL parts can be divided mainly. Actually, remember we talked about the different language. We said that we have data definition language, we have data manipulation language, then we do have actually query language and etc. So, but I prefer to put them under the data definition language and the data manipulation language. What's the data definition language that we did before? It's the language that provides us with a set of commands which allow us in order to define the relation scheme. Okay, deleting relations, modifying the relation schema. So I'm just or mainly focused on handling the schema itself, of the relation itself. So I'm not talking about the instance. So you're not gonna insert, for example, a new student or delete your new student. No, you care or mainly focus on the schema itself. The student schema, for example, if you have a relations called student, okay, you can specify, you're gonna say, okay, I'm gonna add some attributes, delete some attributes, add a change, etc. Okay. The data manipulation language on the other side, it provides an ability in order to perform, let's say, extract information of the language of the database, and also you can modify or perform like insertion, deletions, and updating, let's say, tuple of the database. I know we talk about this one data manipulation language. We can divide this one data query language. There's some textbook, but it doesn't hurt if we put them together. So for the data definition language, we do have a set of commands or other, let's say, features we can perform. We can specify the integrity. So SQL data definition language in this part is going to include a set of commands in order to help allow me in order to specify the integrity constraints. For example, you can specify the primary key for the specific attribute or the set of attributes. Okay, you can specify for an attribute that never has null value. You can specify this attribute must be within a specific number of value. For example, you can say the semesters either fall, spring, or let's say summer. Okay, something like this. You can define a user. Using the SQL data definition language in order to define, let's say, the view. We talked about this one before. You have like abstract, let's say, the logical level, which, for example, you have a set of relations or tables or general schema. Then after that, we can specify that not everyone has the same access right to every single or the whole schema that we have. For example, assume that you have a table R which contains, for example, ID, name, and the social, let's say, social security number, salary, and etc. You can define a view, which in this case, like a portion of the data, you allow that for some user to access a portion of the data, not the entire data. So you can specify a view to say R1, and this one contains only the ID and name. So it looks like you can hide the social security number and the salary from the user. We're gonna go over this one later in more details. We can do have like come up with a way that to control the transaction or transaction control. I know we covered this one, some textbook that said we do have another language it's called data transaction control. Okay? This is the way of transaction control query action, which allow you in order to do what? In order to specify the beginning and end of the transaction. We're gonna see this one later. You can specify like a set of commands. We say, when I say commands, that means SQL queries. Okay, a set of them. You can specify this one, and you're gonna say, oh, this one, this is the begin, like a block, and this is the end. At the end here, you can specify whether you're gonna say commit or rollback. Okay, so either you're gonna reflect the change that had been done within this block, with these commands, or you can say ignore all of them and done whatever we have done in this part. We're gonna cover this one and see how can you perform that. But SQL is allow us to perform that. We can show you some commands which allow you to perform this command. Okay? We can use embedded SQL or dynamic SQL. In this case, the way that we're gonna inject your SQL within your programming language or your code or the programming host language. That's what we're gonna do in the class project. In the phase 3, what you are going to do, you are going to build or create your, let's say, use Java code or Java programming language or Python or whatever, PHP or SP in order to try to communicate or access the data. So just speaking, when you access the data, you are going to translate somehow the SQL query, either gonna inject it as like embedded, so in this case, somehow the same thing that we're gonna try to inject, let's say, PHP code within the HTML page. So that's what you're gonna think. We say PHP, something like this, then after that, something like this, right? PHP, then you write PHP code. So somehow you're gonna say inject, you can say this way, not exactly, but you can say begin SQL, then you put the SQL command, then and after that you say end SQL. So this part between the begin and end, you're gonna write normal SQL command, select a star from whatever or insert whatever. Oh, the other thing we call this one dynamic SQL, where you're gonna collect some information from the user, from the, let's say, forms, etc. Then after that, we're gonna create to build, let's say, SQL query. Which the most used one, which is the one that we are gonna cover in the class when you talk about the advanced SQL. that dense SQL. So we have like SQL, we're going to divide this one 3 parts. The introduction to the SQL with today's lecture. I'm not sure if they have time to finish this one today or not. So next lecture, we're going to talk about the intermediate with the more advanced commands. Then after that, we do have the third part, which is called the advanced, which is the one that's going to mainly show you the way that how can we write Java code or whatever acts to the database management system using external programming language. Okay? Then we do have another thing we allow us in order to perform as chief or provide a set of commands. All of them are going to be data definition language. If you put this, all of them, because you're going to change your handle or access or modify or communicate with the schema in general. So you can specify or put what is called authorization. What does that mean here? You can specify the access right to the user, to the relation. Who can access what? Grant access right. Grant, for example, someone, I can say, for example, we do have user 1 or user 2, user 3. User 1 can perform select on this relation. User 2 can perform, for example, insert and delete. Something like this, you see. User 3 can, for example, only update one specific attribute, something like that. So you can, specify the access right or permission or authorization on the data. We are going to cover this one later in advance when we talk about the grant, etc. Okay, so those are the SQL parts that we try to cover some of them. So generally speaking, we can say SQL parts or SQL commands in general, it might be like data definition language or data manipulation language. Okay, so data definition language, for example, you're going to see that some command create table, drop table, delete table, for example, alter, change the the schema of the table. Data manipulation language, for example, you can say insert, delete, or update a new tuple or set of tuples. So mainly data manipulation language, I'm going to handle with the instance. Okay, data definition language with the schema. Okay, and also we do have a grant, revoke, we're going to say data control language, or you can say, but this one is going to be for the control part, which is going to be, we add, here I add everything in data definition language, which allow you in order to perform, let's say, grant or revoke for the access right or authorization. Transaction control language, which allow you in order to commit to rollback. We're going to see that how can we perform that. Or data query language, which allows in order to perform or retrieve or extract the data from the table relation. Clear? So the first thing you're going to take a look. So this is, we can summarize everything here. Data definition language allow me to perform the following. Schema, create a schema. Specify, for example, when you create a schema, definitely you're going to tell me for every single data type or every single attribute of the relation, you have to specify the data type associated with this one. It looks like when you create or build your programming language, the first thing you're going to do what? You have to define all the variable users used in the system, and also you need to specify what the data type of every single variable, right? You can specify the integrity constraint. We're going to see them here today. You can just say create index with something new. In this case, what do you mean the index? Some will say a data structure we can build, which allow us in order to expedite or speed up the access of the data. So if you take a look at any textbook, okay, when you try to looking for a specific subject, what do you need to do? Are you gonna go page by page in order to figure out which page you need to, where the page that contains the information looking for, or go to the index with the first few pages? Then you can see, for example, looking for SQL command or insertion or deletion. You're gonna say go jump to the page 15. This is the index exactly. We're gonna try to. I will show you how to build this one and how this one is gonna help us in order to expedite the access data, make it faster. Okay, security and authorization information for each relation, and also you can specify, we're not going to cover this one here, but we can, when you create an index, when you create a table, you can specify, for example, how can your data be stored in the lower level, in the physical level. Clear? Okay, enough from talking too much. Now let's start with the classes. The interesting part of today's class. First, I'm going to start working with a SQL, okay, or SQL, either is fine, by the way. So SQL language is case insensitive. So both keyword and identifier for the most part will be what? Case insensitive. So either, for example, you can say select, or you can select. Either is fine. Equivalent. Okay, that's great. SQL statement, generally speaking, when you write this one, this document, you have to end this one with a semicolon. Okay? That's in order to make sure this is my command or this is my SQL. Okay, what else? How could you say comments or write comments or comment sub the SQL parts? The same thing in any programming language. There's many ways in order to comment, make sure that this part is going to be commented. In other words, when you combine another programming language, try to execute or combine your code, it's going to ignore this part. So the SQL do have two ways in order to do that. I'm talking about the standard, okay? Then after that, we're going to see some examples how can we use this one using the Postgres. So the first one, you have double dash, and whatever you write after double dash, the system is going to ignore this one. This is the single line, okay? And we do have a multi-line comments, the similar to the one that if you are familiar with the C language, okay? So in this case, we can use the forward slash, followed by, let's say, asterisk, okay? Or they say slash star, if you prefer to use that. I can say slash star, and maybe you have multiple lines, then after that, star slash. So whatever you type this one here, within this one, the system is going to ignore it. So, okay, we know that the SQL language is case insensitive. We need to end every single SQL query with a semicolon. Then after that, this is the way how can we create, let's say, comment, to say, blocks or line in the SQL. Okay, what else? Now let's start talk about the database. When you work with the database in general, now we talk about the database university, okay? We say you have a university database that contains a lot of tables, right? In order to work with this one, you have to create a database first, always. So you have to say, I do have a database. Then within database, for example, it's called university, okay? Then within database, you're gonna specify you have to create the tables. So the database is what? It's a collection of tables or relations. Okay, so first thing, you have to create database, then after that you have to connect to the database, then after that you start creating your tables. You are going to do this one, as I mentioned here, as I mentioned at the beginning of today's lecture, I've said, I'm going to show you maybe tomorrow morning, I'm going to post to say the first lab. What do you mean? But with the lab, the one or the set of instructions that help you in order to prepare your computer to use a Postgres as an example. Okay, so we're going to show you, walk you through. I think if you have a time today, I'm going to go over this one. I think I maybe spend maybe the last 10 minutes just to go over this one to create database, then show you how to use the Postgres to create database, then how to build this one, okay, the add, okay, some tables, fill with data, then perform some queries. So starting with today, you can follow me exactly. Whatever we cover in the class, you can practice one by yourself. Okay? Anyway, first you have to create database. Then after that, you have to connect to the database. Why you need to connect to the database? Because it might be the case that we have many databases. So you have to tell the server, whatever, Postgres, MySQL, whatever, which database you want to perform these commands. Otherwise, the server is going to say, okay, select the star from, let's say, student. What student? You have to tell me first the database. So you have to, after you create database, you're going to create one time. You have to connect this one every time you want it to perform whatever, access the state and to do some operation. Clear? How can you connect this one? After, yeah, first, how can you create the database? This is the command. Create database, and you have to specify whatever name of the database, then semicolon. This is the command. Of course, after you connect to the Postgres, MySQL, whatever, they're going to have like a command prompt, whatever the value of the command prompt. So it looks like you open a terminal somehow, okay, to the server. Now starting to communicate with this one, okay? When you type whatever command you have to type here, then after that, enter. So in this case, I'm going to create database. This is the command, okay? And space, what's the name of the database? Whatever you want. I'm going to say create university database. Okay, the name is university, okay? Then after that, you have to connect to this data. Connect to have a different ways. Now we're starting to talk about different database management system. Actually, for the Postgres, you can use connect or you can use a /c. Now remember, we said at the beginning we talked about the database, etc. We said most vendors of the relational database management systems have added features to the standards. So this one, some features. Instead, you write, for example, /connect, you can say /c. Some of them you can use just use. So it depends on the database that you work with. I think MySQL is gonna use, or Oracle, yeah, you can use, say use, and the name of the database. Now when you put this one, this means the system is going to say, it looks like you said CD change the driver or the subdirectory to the database universe. Now whatever you type here is going to be executed against this database universe. Okay? Okay? So we create database, I connect to the database. What else? Now let's start talking about how can you choose the names of the SQL names in general. For example, the name of the attributes, the name of the, say, tables, the name of the, say, the database, whether there is a structure or not. So it's like conventional way in order to build the data. The same thing with any programming language. When you learn this one, they show us that in order to have a valid variable or identifier, you need to follow these conventional rules. Okay? Table, columns, attributes, requires name. And the name is going to be what? On valid names. It might be different from one implementation to another, because I wanted to make sure that whatever I'm going to type here can work maybe with different database management systems. Postgres, Oracle, MySQL, etc. If you follow these rules, you don't have a problem to migrate your data from one place to another place. So the good practice to do the following, or portable rules that means you can migrate data from one database to another database if you follow this one. When I say database, I mean database system or management system, okay? The first character should be alphabetical, and the rest is going to be alphanumeric or underscore, whatever you want, okay? So for example, 5 A, B, C, this is wrong, okay? It's not valid one. And try to use the same case in the data manipulation language that you use in the data definition language. In other words, when you create schema, okay, you're going to say, for example, I do have attribute ID. You use uppercase. And the ID, for example, you said char 9, and etc. So later when you work, and this is the data definition language, later when you try to access the ID, what you're going to do, you're going to say select, for example. Okay, to use ID, we said it's case insensitive, but in order to make sure that we don't have any issues, if you translate or migrate whatever my system to another database management system, try to use the same case that we use in order when you create this schema. If you use uppercase, use uppercase, just to be in safe side. Clear? So far, so good. Okay. So just speaking, the SQL data types is used to what? Or data type in general is used to define the value that an attribute can contain. When you say specify that, you said I do have an attribute as ID, for example. I do have an attribute as name, for example. I need to define the data type. What does that mean? The data type, as I mentioned, the SQL data type. I'm going to show you SQL data type. The same thing when you learn Java or any programming language, each of them has its own way to define the data types. And Java, for example, string or varchar, a char, whatever. Okay, most of the cases going to be the same. Okay, so anyway, this again, the SQL data type is used to define the values that to say an attribute can contain. So here for the ID, I'm looking for what is the data type for the ID, for example. Okay. By the way, every attribute in the relation of the table is required to have a name, and also it's going to have the data type. Okay, when you say the ID and the data type, for example, integer, this is the name of the attribute, and this is the data type of the attribute. Okay, so the SQL Standard supports a variety of built-in types. Okay, those are what's called built-in. Those based on the standard. You check for the database, your favorite database management system might be there is a minor change. Different. It's not the exact one. Most of them are going to have the exact one, but as I mentioned, we can not every single data vendor is going to implement the exact thing that we have in the standard here. Okay, the first one is char. So this one, what do you mean by char? Char is like character. Remember, like a string. Okay, but what we're going to say, for example, assume that I do have attribute A, and the attribute A has maximum 5 characters, or has only 5 character length. Or, yeah, let's say the ID. How many characters do we have for the ID in the IIT? I remember we do have start with A, then a number of digits, yeah? 9 in total, I guess. assume it's 9 in total, okay? So that means every single ID must have 9 characters, okay? So in this case, I'm gonna say it says char, and will be 9. So in this case, the system is gonna say for this ID, I'm always reserve 9 bytes. Total is 9. Okay, so fixed. It looks like string 9. This means for every single attribute or value, you're gonna reserve for this one, I'm gonna reserve 9. Clear? Or sometimes we can't use character and you specify that. Okay, we have a varchar. What does varchar mean? The varchar means the character varying. Okay, this means it's not fixed. It depends. So what does it mean? For example, the email address. Okay, if we sorry, if you have the data or attribute is email, what's the data type for the email? I think, can you use a char? 5 or 10? No, because for every single user, the data might be changed or might be different. That's why I prefer to use a varchar, or let's say a string with variable length. And every time for every single tuple, it depends on the value. If I've said they need 10 characters or 10 bytes or 10 characters, I'm going to reserve 10 characters to store the data. Actually, 10 plus 1. I'm going to show you how exactly. If you want to have an example for this specific attribute, particular tuple, the value for the user, the email, for example, for your email, maybe you require to have 20 characters, my email requires 50 characters. So here, the size is different, so I prefer to use varchar. When you say varchar, let's say 25. So the maximum value is going to be 25. The minimum, it depends. So for example, here, when you store this one, the system is going to say what? It's going to reserve two things. You got 25 plus 1 byte extra. So we're going to use the first byte in order to tell me, for example, assume that we have the user 1, the email a@b.com. For example, 4, 5, 6, 7 characters. So in this case, I'm going to reserve this one 1 byte 7 and put the characters here. I'm not going to reserve 25 because it's going to be variable. Yeah. For someone else, too, for example, A, B, C, whatever, so maybe 20 characters. So in this case, the system internally is going to say this is 20, and I'm going to store the data here. So again, I know it's 25, but I'm not going to reserve 25 for every single tuple in this data. It depends on your data. That's why we call this one the variable length, or variable length character string. Integer. If the data is integer, you know that you have a small integer, you have integer, yeah? And when you say the integer, that means, it means I think 4 bytes, and small integer 2 bytes, if I remember, I recall. I don't recall this one, but something like this, okay? So yeah, I think the integer 4 bytes, actually, yeah? And the small integer is gonna be 2 bytes, signed integer, okay? Numeric, let's go with the real double, then after that float. You can use the real, okay? Real number or double per session. What does that mean here? So like a floating point, we have 3.5 and etc. This is the way how to store that. You can double. Remember, you learned that in the programming language. Teachers show us that when you try to store the data that contains a decimal point, and this information we need to make sure that the data is going to be stored 100%, or it must be accurately stored and can be retrieved. In other words, let me start again. Assume that we have, for example, 0.1, okay? You said 0.1 plus 0.2. Say print, for example, f. Give me the value. The result is going to be 0.3, right? Assume that you're going to say print f 0.3. The result is going to be 0.3, right? Because the data is going to be stored accurately. If you assume that the data here, for example, A and B, and the value of both of them is going to be double, for example, or here. Okay? The problem here is if you specify the precision. Precision said, I want a precision up to 20, they say digits. If you do this, I think you can do something like 0.20. F, I remember, this is the C. When you print this one, okay, 0.1 plus 0.2, and the same when you say 0.3. So the system in this case, you're going to see sometimes 2, 9, 9, 9, 9, 9, whatever, and this 1.3, 0, 0, 0, 0, 0, 1. Why? Because when you use a double and real number, we cannot guarantee that we're going to store the data accurately. So in this case, if you have a monetary data, or you have like data have high, that require for me to have high accuracy, especially the one that I'm talking about that has or contains, let's say, sensitive decimal points, and the data sensitive based on for the accuracy. So in this case, what I need to do here, I'm going to use a numeric. When you use a numeric with a big integer, I guess using the Java, something like a big decimal. That's why you use a big decimal in Java. Here we're going to use a numeric. Numeric, I'm going to specify two things. I can say, for example, numeric, for example, 5,2. What does that mean? The total, the data that contains 5 digits. And we have only 2 after the decimal point. So the system, when you store, for example, in this case, 3.250, okay, you're going to restore the exact value. The system has a different way, of course, to convert this one to the string in the way that in order to make sure the data can be accurate, can be retrieved. Okay, anyway, the takeaway from here, if you are care about the accuracy of the decimal point, use a numeric. If not, use a real or double. Okay, and more are going to be covered later. So this is the basic, the data type that you need in order to define your attributes. When you need to use a char or varchar, let's give you an example here. Assume that, actually I talk about this one, we say the char is going to be, both of them, they have the size limit, okay? And the char, you can specify what the exact number, fixed number of characters going to be reserved for every single attribute. And the varchar is going to be here variable. So of course, you're going to specify the maximum, the limit, but depends on the value going to be stored in the total. Some of them are going to be consumed the whole limit. Some of them consume some of them. Okay. So the question here, or generally speaking, if you know exactly the value or the values are maybe exactly or approximately going to be the same, then in this same length, in this case, use a char. The same example will give you the ID and the IIT. Okay. So what I've done here is that the ID, since we assume that the ID A, then you have number of digits, we assume the total is going to be 9 character. So in this case, it's better to use a char 9 because every single element or tuple or student must have this value, must have 9 character fill in this one. Okay? Or maybe approximately, okay? Varchar, that means where they can be very wide in the length. For example, the email address, or the names or last name. Some last name maybe have 100 character, I'm just exaggerating, some of them 2, some of them 1. So you see that in this case, it does make sense to go reserve 100 character, while most of the case I'm gonna maybe use less than half. So take a look here, we have, for example, if you give you an example, data type for the zip code. In order to store the zip code, what data type that we're gonna use? The first thing came in your mind, maybe you're going to say, okay, looks like I'm going to store, let's say, the numeric value. This is numeric, yeah? Integer. I can use the numeric with integer. For example, the zip code with IIT with 6616. Do you think this is a good idea? Actually not. Why? Because we do have if you have defined this one as an integer, so we know that we do have like a zip code. I know the zip code is mainly the 5 digits, but there's some of them or some states that have, or county, they have what? They have leading zeros. If you have a leading zeros, you're gonna forget them. For example, if you have something have 0, 0, 1, 2, 3, for example, this one can be stored 1, 2, 5. Sorry, 1, 2, 3, 1, 2, 5, for example. So in this case, we cannot catch this one here for the integer. So the integer doesn't work. And we have another problem here. So as I mentioned, many East Coast zip codes start with 0. Numeric type won't include the leading zeros. We talk about this one. Another problem, the US mail might be, or maybe have the expanded zip code, which they have extra 4 digits. So in this case, I cannot use this one for the integer here. And it's not, you can say, only character can be 5 in this case. We do have another problem. What if the data that's stored in the database that they have, that maybe include people that are from outside the United States? Maybe they have a foreign address, okay? Which they don't have, let's say, they they use non-numeric values. Especially in my country, we don't use a numeric value. You have a non-numeric value in order to specify the code, for example. Okay? Or the candidate, why go away? So in this case, what we're going to do here? So it looks like the integer is not working. And that's what the one that you start looking at when you start doing the phase 2. When you convert your data, you need to build to create a schema. Yeah? So we create a schema after specifying and said, this is attribute 1 and attribute 2 with all the set of attributes. You need to specify the data type for each attribute. Okay? So the chosen one, it depends here. Okay? Either char or varchar. It depends what you plan to do. If you are going to store the information about the United States, you know that the data or the zip code must contain 5 characters or must contain 9 characters. I'm going to include the extended one. If you want to, for example, store mixed information, United States, international, so maybe varchar 20. So it might be 5, it might be 9, it might be 16. It depends on whatever data. That, I mean, estimation, okay? So it depends on the data that you have. It depends what kind of information you have to store. And you can take a look to the sample data to see, to decide what's the best data type that work with. Monetary amount, I've talked about this one before. We said it's better, numeric, you have to use the numeric in this case. And you have to specify, for example, I remember this one. I think we said we have a rounding problem, yeah? Rounding problem with the decimal number that's stored if you don't store this one in numeric value. Clear? Question? Okay. How can you create table? I do have a create database there. In order to create the table, this is the command that we're going to use. Actually, we have different variation, okay? You're going to say create table, the name of the table, then between 2 parentheses, you have to tell me what the attribute name and the data type of each attribute. Okay? So you can say, for example, attribute A1, data type of A1 is D1. For example, ID, char 5 or char 9, comma. Name, varchar, for example, 25, comma. Email, varchar 20, and etc. Okay? And late after that, before you close the parenthesis here, you have to tell me what the integrity constraint here. You can specify the integrity constraint here. You can, what do you mean the integrity constraint? You can say, for example, attribute A is the primary key, B, C, D, whatever attribute, set of attributes that are the foreign key constraint, or not null, or whatever. I'm going to go over this one, but this is the way. Or another thing, maybe after you define whatever the attribute name, the data type, you can specify the column, or attribute constraint here. It depends on you. Either put the constraint at the end, or in front of each attribute. Once you define this one, you tell me what the constraint that you have. Okay? Let's go over the one example. I'm going to create a table instructor. The table instructor contains, as we know, that ID, name, department name, and the salary. All right? This is the instructor. So if you take a look at the information here, how can you create the schema? Now I need to create table, the name of the table, between 2 parentheses here. You have to write whatever you want. And the way that you do, the attribute, okay, name, space, the data type, comma, the next attribute name, space, data type, comma, and etc. Okay? And the last one, there is no comma because this is the last line. And you can specify here if you want to, for example, the ID. I want to define the ID as going to be primary key. Again, space. I'm going to say primary key, comma. This one, for example, name, not no, comma, and etc. You can specify what one. So if you take a look here, the data that we have, the ID must be exact 5 character, up to 20 character can be stored. That's the meaning varchar, and the same for the department name. The salary is going to be what? Numeric value. What does that mean here? That means we do have in total 8 digits. Okay? 6 before the decimal point and 2 after the decimal point. So the total is going to be 8. That's the meaning here. So for example, you can store, if you have integer or any number, or to say value, numeric value, or say real value that contains decimal point. If this value contains up to 6 digits before the decimal point, you can store this one accurately here. If more, then we cannot store this one accurately. So it depends on the data. You need to make sure, take a look at the data stored there. Again, take a look at the samples of the data in order to decide the best data types here. Okay? So again, we talk about the integrity constraint. Okay? And I covered this one in the previous slide, but that's the way that how can you define the integrity constraint? We do have many ways, or many types of the integrity constraint. The first one, actually, by the way, you have many ways in order to enforce them. Either while you create a table, you can specify the integrity constraint, or even after that, after you create the table, by the way, you're going to create the table only once. Okay? Then you can, for example, later or after that, you can modify the table by altering the columns by adding some, let's say, integrity constraint. Okay? One of them you can specify not null. So you can say this attribute never has or can get null value. You can specify for the set of attributes like as a primary key. You can say 1 up to n. Those is a primary key. Maybe 1, 2 attributes. You can specify the attribute as well, the foreign key. And this is the way how to write this one. You're going to say foreign key, the list of attributes, references, what the foreign key is going to be. For example, you can say foreign key here, department name, reference, for example, department. Right? And the foreign key here. That's the way you can do for that. So in this case, the SQL, by doing or using these integrity constraints, it's gonna make sure any update, any modification to the data that violates any of these integrity constraints that you specify in the create table or within the table scheme is gonna be rejected. Okay? I'm gonna see how can we handle this one in more details. It's actually gonna be prevent this one, or it's gonna be rejected. In most of the cases, okay? Because I'm gonna revisit this one. So here we define the table, or case from the beginning, for example, assume that this is the way how to create the table, and just specify the primary key of the ID here. Or, by the way, either put this one at the end or here. Either is fine. Either here, or the end, or here. Okay? So what does that mean, primary key? There's been no tuple in this relation. They're gonna have the same ID. They have the same value of the ID, right? And also, by default, the primary key never has null value. It looks like you said here is not null and unique. Okay, so primary key, when you define primary key constraint, is by default is like not null value and unique at the same time. Okay, so there is no need to say, for example, primary key. I see how to do this one. Assume I wanted to say the value char here is not null or not null, space and primary key. If you take a look at this one, there is no need to specify not null because the primary key by itself is said is not null and unique. And you're going to see we can use unique. Unique, that means it's not key, but I can say make sure this attribute must be unique. There is no duplication. There is no tuple. They're going to have the same value based on this attribute too. Okay, but it might be null in this case. That's why I said unique. Clear? The primary key can have or can be have multiple attributes, not only one. It depends on the data that you have. Okay. So this is how can you specify the foreign key constraint. For example, you have a database department name, and the foreign key is going to be referenced what? The department here. The question here, why I don't need to write the department name here or the attribute here? The simple answer for that, since it's one attribute, and you know it's going to be referenced to an attribute in the department, and it's going to be referenced the attribute in that department relation, and that attribute is going to be the primary key, and it's only the primary key. So in this case, there is no need to do that, to define or specify what's the name of attributes. Although it doesn't hurt if you don't do it, or if you do it in this case. I will give you a next slide. I'm going to show you that what if we have the reference to, let's say, the relation that might have, let's say, more than one key as a primary key. So in this case, you have to specify the attribute. Otherwise, that I mean in the Postgres. Otherwise, the Postgres is going to give you an error in this case. Okay. So what the foreign key constraint states is that the values of the department name that's stored in this instructor relation must be exist at the department relation. Otherwise, it's never happen. We cannot add this value here. And especially every time we're going to try to insert, modify the instructor relation. So the system automatically is going to check all these constraints to make sure that there is no violation to any of them. And this is just an example to some relations definition. Okay? And here, the example that I told you, for example, here we have to say foreign key here. You said, this is what the primary key in this relation. The primary key, as you know, takes there'll be all the information, okay? The ID, course ID, and the section ID, semester, and the year. All this information will be the primary key. Okay, what else? We do have a foreign key, which is going to be what? It's going to be to the relation section. The relation section contains section ID, course ID, semester, and year. Since we have more than one attribute here, and those are going to be like reference to what? To an attribute in other relation, and that attribute has more than one primary key. So in this case, you have to specify that. So in Postgres, if you didn't write this, the system is going to give you an error. So it depends on the database. Most of them, they don't accept that. They say, since you reference more than one attribute that we use as a primary key in the other relation or reference relation, so in this case, you have to specify the exact attribute here. Here, whatever reference. Maybe two of them, maybe some of them, so you have to specify them. Clear? And there's another table with the course. So if you can take a look at the database, it looks like what we're doing here is like the phase 2, after we have like a scheme of the database that we have, now starting building the, using SQL in order to create the tables. And the table, this is the structure that we're going to build or use, okay? Okay, if you try to update or modify the data here, just to give you an example for the insertion and deletion, then after that I'm going to go over this one in more details, okay? If you try to insert something in the data here, or modify something, generally speaking, when you build your data, create your table, the table is going to be empty. Nothing is stored there. I'm talking about the instance. So the instance, if you try to achieve the information of that table, it's going to say, I don't have anything. The only thing going to display to you was like the header that contains the list of attributes or whatever you try to achieve from this data. If, for example, you said select a star from the table R, assume that we build the table R, okay? Then in order to retrieve the data, I'm going to say select, for example, star from R. The system is going to say check out. Do you have any data? No. So it's going to display all the attributes, for example, attribute A, B, C, D, E, and nothing can be displayed here. Done. Okay? So we need to fill the tables with data in order to starting working with the data. Okay? So I'm going to reform. Sorry. Sorry, I tried to mute them. Yeah, I'm going to remove this one from the recording. Anyway, so I'm trying to add a new tuple. In order to insert, this is the command. So you have to use command called insert. And the command, again, this is the structure or the syntax. You're going to say insert into what? Into specific table. You have to tell me the table, for example, our case R. Insert space into that table. And here you can specify what the list of attributes that you want to insert. I'm going to insert attribute 1, 2, 3, 4. Then after that, you have to tell me what's the values. Okay? The first value, the second, the third, etc. And the question here, why you need to specify the list of attributes? Sometimes you're going to see later, when you create your table, let's give you an example here, table relation R, you can say A, B, C, okay? And I'm going to define A as a serial, okay? So in this case, this value, the system automatically going to increment every time you insert the tuple, the system going to give like a number one, increment the value of the previous value that's stored in the serial for this attribute plus 1. For example, I insert a new tuple. The system automatically going to say the value of A, since defined as serial, or auto increment attribute. So this case is going to be equal 1. Then I need from you just to give me the value B and C. So in this case, you have to say that I need to table R, and you specify the value B and C, and values. You have to tell me what the value of B and C. Okay? Don't give me the value of A. Or sometimes you're going to specify different order than the order that the data using the data definition language. For example, you have the relation R, and attribute ABC, and you want to insert ABC, but you want to provide me with the value B first, then A after that C. This is the values that you want to provide. So in this case, when you say insert here into relation R, you have to tell me here the first one attribute B, the second value is going to be for A, the third value for C. Then after that, give me the values here. So the value is going to be, for example, what attribute B? It's going to be 5, A is going to be 60, for example, C is going to be F, something like that. Okay? So assume that we are going to insert this value to the instructor. I'm going to provide you with all the information in the table. So there is no need in order to tell me, for example, instructor ID, name, department, name, and the salary. Right? Because this information, you give me all of them. I think you notice something. If you have a char value, varchar value, in other words, string value, you have to put this one between single quotes. Must be, in order to be string. Okay? And the value is going to be appear in this case in the same order as the table attributes, so there is no need to specify the attributes here. Make sense? So I'm going to specify the data or add attributes. So we add this data. Okay? So this command and the previous command are the same. This one is here. The only difference here, I don't need to specify the order here because they have the same order, or it doesn't hurt if I specify the order. But here, I feel like you add extra piece of information that I don't need, especially if you're going to give me the same exact order that we have in the table when you define locality. Okay? What if I have value or one attribute has a default? I'm going to talk about this one later. But sometimes when you define an attribute using the data type, and you say the default value of this attribute, for example, 0. For example, the GPA, and the default value can be 0.0. So if I didn't provide a value for this attribute for a specific student, for example, then the default value can be 0.0. So in this case, you can ignore that. Okay? For example, assume that we have the relation R that contains the student ID, name, and the GPA. Assume the default value of GPA is 0.00. Okay? So when you insert the data here, I'm going to see insert, a new tuple. In this case, I can say, I don't need to specify the attribute here. Values, okay, with the ID, 1, 2, 3, with the name, Alice, then done. If you didn't give me the value for GPA, the system is going to say, okay, what the data type? It's not serial, it's not auto-increment. Take a look. Do you have a default value states or defined when you define the relation? Yes. What's the default value? 0.00. So in this case, we're going to have a new student and going to have the name is going to be 1, 2, 3. The ID, the name is Alice, and the GPA is going to be 0.0 if you assume the default value is 0.00. Okay? And we can change 0.00 to something feel happy here. Okay, happy face. Question. Why do we need to primary key, by the way? What if, when you define our table, if you take a look here, just to show you the way that we define the table instructor. Yeah, if I didn't define that, I didn't define this information. Okay, that's what I have, okay? So if you say insert into, let's say, instructor, let's say 1, whatever information, okay? So values. By the way, you can insert multiple value. How to do this one? Comma, another value. You can specify 1 again and another information. So what's gonna happen here? The system take a look at the data that we have. I said, okay, you said you want to insert something. You want to say the data will be ID, name, and etc. You said the first one, value 1, the ID, the first attribute is going to be ID. So insert here, ID, and insert the rest of the information here. Then you said you want to insert another ID is equal to the same one, the same value. The system check, do you have a primary key? No? So it's going to do, it's going to be insert the same item, another name, for example, another instructor with the same ID. Why? the system allow us to do that because I didn't specify the primary key here. But if I specify the primary key, the first insertion is going to be okay. The second one, the system is going to say, hey, wait, you cannot do this one. You cannot do that because you cannot store, you have two instructors, they have the same ID. Because the ID is the primary key, so I'm going to disallow you to prevent you to perform that. Okay? Make sense? And that's what we cover here. And that's what we talk about. Assume that you insert, we can add, for example, multiple instructors with the same ID if we don't have a primary key constraint ID. And that's what we did here. We don't have primary key constraint. I add this data. Then after that, I'm going to insert this one again. Or maybe you can do this one here, as you mentioned, comma, and just write this one here. If you have a multiple tuple, you want to insert them. If you do this one, the system allows this one and this one. So now we have a Bob and Smith. Both of them, they have the same ID. So when you try to retrieve the data from the instructor that equal this ID, the system is going to provide us with two different instructors. But if we define the ID as a primary key, the system allows this one to go. Assume that we don't have an instructor that has this ID. Then after that, you try to do this one, the system is going to say, wait a second, you can't. Okay? I'm keeping saying, okay, if you have a question, please feel free to stop me at any time. The other one we say, how can we delete or remove data? Insert, that means I'm going to insert a new tuple. Remember, I'm just mainly focused about the instance of the data, the content of the table, of the data itself. Okay, so adding a new instructor, deleting a new instructor, and etc. I'm not talking about the schema here right now. So delete is used to erase record tuples in the data. This is the syntax. Delete from, it's like if we compare this one with insert, enter. By the way, you can write your command in one line or two different lines. I prefer to do this one or two different lines, separate lines, in order to help us to understand what's going on. But in your case, you can say insert, enter, relation R, values, in one line, it's fine. Okay? So delete here, insert, enter, and the values here. And here you can delete, of course, relations. And here you can say delete from the table. And sometimes you do have a condition here. What does that mean? Of course, do you want to delete everything or not? Do you want to delete the data that belongs to a specific user or that satisfies a specific condition? That means, in this case, we're going to use the word class here. Okay? So let's take a look at some examples here. Assume that I wanted to delete the student record or data tuple with this information, this ID. So in this case, I'm going to say delete from student where the underlying words are the keywords that must be exist. Okay, where the ID of the student is equal this number. So the system is going to search for every single tuple in this student relation and see whether anyone satisfies this condition. Any tuple satisfies this one, or every single tuple depends on the command. In this case, of course, we know that the ID is a primary key, so we know for sure that we have only one tuple that's going to satisfy this condition. So in this case, we're going to delete it if it exists. Sometimes maybe you're going to say where the GPA is less than 2.00. I need to delete all of them. Also, in this case, maybe we have more than one tuple that will be deleted. Okay? If you want to delete all the tuples or records from the student, what does that mean? Make it clear, empty. So in this case, I'm going to say delete from. I'm not going to say where. So in this case, there is no condition. If you wrote this one, the system is going to say, okay, it looks like you need to delete every single tuple here. By the way, in the delete, I cannot delete only an attribute. I'm going to delete the entire tuple. The same thing for the insertion. If you want to insert a tuple or data, or an attribute, you have to insert the entire tuple. Okay, you cannot insert only a specific value for a specific attribute for a specific tuple. And if you want to modify that, delete that, or do some change, that means you have to do update. That's a different story. Clear? So this insertion and deletion is going to be for the entire tuple. So if you do this one, the whole data that's in the student is going to be deleted. But still we have the relation called student, ID, name, and the information can be here there, and the students still the data can be there, but it's going to be empty. There is no data here. Okay. There's another thing. What if I wanted to delete the table itself? When we say delete the table itself, especially in this case, I'm going to delete the content of the table plus the structure. So the table is going to be not exist, or the schema I mean, with the content. So if you want to do that, you're going to say drop table, and you have to specify the specifically say the relation of the table name that you wanted to get rid. Assume that the table relation R, when you do this one, so the system going to go to the relation R, delete everything inside this one, then delete the whole thing. So later, after this step, if you try to access the relation R, or table R, the system is going to say, I don't know anything about this table. The table does not exist. It doesn't exist anymore, or it's not there. Okay? If you want to delete all the table, as you said, for the specific relation, this one is not gonna delete, is not gonna touch, I mean, the schema of the table. Drop the table, that's means you're gonna delete the schema and the content of the table. Can you do drop database? Yes, but please be careful. Okay, don't do it. Of course, if you try to do this one, maybe in your data, yes, but in the real, when you work later in the real world, not everyone can do this command. I think only maybe one or maybe few users, they can do that. Delete the entire database. Okay, so you see in this case, drop the database. This is the command. Then I said after that you have to specify whatever the database. I use different names as a bank. I don't care. Don't you remove or delete the database university after you create it, because you have to do this one again. You create it and it's okay. What if I wanted to update the content? I would say the structure or the schema of the database object. Just say, assume that we have one relation R, I create R that contains A, B, C. Then after we fill this one with data, etc., we create a table and said, oh, we need to add another column. I forget that. There is a column we need to add here. For example, I need to add a column D. In order to add this one, what we need to do here, you need to change, or to say, modify the schema of the relation. In order to modify the schema, you have to use alter, okay, space what? The table, okay, the name of the table, in our case R. Then what we need to do here, I need to say add, I didn't have space, so this is the commands. Add what? Attribute D. What's the data type of D here? For example, let's say char 5. When you do this command, the system is going to add another column. But I have a question here. So what is going to happen to the data that already stored there? For example, assume that we have a different color. Assume that we have one Alice F, 2 Bob C. For example, something. Or let's say A. Why is it? This is F. It's okay. And C. Okay. So we already have two tuples here. Now, after I add a new column here, D here, so it looks like what's going to be the value here and the value here, because I add this column after I insert this data. So by the system, by default, it's going to do what? It's going to assign a null value here for every single attribute added after you insert a tuple to this data. Okay? Then later you can modify this value. Okay, you can specify. Okay? Or you can call this one as a default when you create this one. Or maybe you're going to say, if you want to have a default value, for example here, D, for example, char 5, then after that say default. For example, what's the default value? ABC, for example. So in this case, the default value is going to be ABC, ABC. Not null, if you don't specify the default. You are going to play around all this stuff after at least in the first lab. So I encourage you after today's class or tomorrow, after I send you the short tutorial, we'll see the lab one, which allow you to prepare your environment, then start practice all of them. Remember, this class, I'm not going to ask you to memorize anything. Just I want for me to understand. And the best way to understand, to practice this one by yourself. So you can create fake database, you can play around with the database, then after delete it, then after that create another one, and etc. And I'm going to show you the lab 2 with the one that allow you after you prepare your environment. I'm going to show you how can you download the database, let's say university, how to fill this one with the data, and you can perform this step in 1 minute maximum. So you can define maybe multiple different databases, and fill this database with the same two attributes. So it looks like we have a replica of the database, and you can play around with them. Okay, keep one for the class, and the other ones or other two, they're the one that you can play around. And again, don't worry if you delete everything or mess with the data, you can reinstall or you can create the table of the data in less than 1 minute, as I mentioned. Okay. So now let's take a look at a very important thing. Now, I know I do have a database. I create the database, and the name of the database is, for example, universe. I log into the database, I connect to /c in the database, the name of the database, whatever, universe. I create multiple tables. I fill these tables with data. Okay, now what is the next step? I need to practice how can we retrieve the data? How can we get some access to the data? So the most famous, important statement in the SQL is called select statement. Okay, it's very important. So one of the most common tasks, as I mentioned, you try to just to achieve the data. Okay, and the most important statement you can use is select. Okay, the select statement is a powerful command which allows us to perform the equivalent of relational algebra. Select, project, join. What we did in the relational algebra, you can do this one with the select statement. The simple select statement contains or composes of select, sometimes we call this one SFW, which select from where. So you have a select something from something where. Okay, this is the simple form. The select statement contains a set of, let's say, class. What do you mean the class? Class in the general terms is just a logical chunk of the SQL statement. And usually is the chunk that theoretically optional. So maybe you didn't need them. For example, I'm going to talk about the where class, which allow me in order to add a command or condition predicate, which allow me in order to filter the data. So not every single tuple is going to pass, is going to be part of the result. The only one is going to be part of the result, the one that is going to pass or satisfy the predicate that I'm going to specify in the where class. Okay, so this is the simple form. Select from where. What's select? Select, it looks like I'm talking about the projection. When you say select here, so it looks like a projection relational algebra. Here we're going to specify what the list of attributes is going to be part of the result. Select all of them, or select ID, name, or whatever. Okay? From that means it looks like you're going to perform a join, yeah, in the relational algebra. So that means it's going to allow me in order to tell or specify which tables or relations that I wanted to access in order to get the data that I'm looking for. And the way when you access the data, you have to tell me whether you're going to use Cartesian product, whether you're going to use join, natural join, theta join, whether you're going to use the left outer join, right outer join, whatever. Okay, all of them going to be specified for the from. Where, as I mentioned, with the where class, it's going to tell us or specify which tuples going to be part or listed in the query result. Not all of them, the one that satisfies the condition. Okay, so this is select a class, this is a from a class, the where class, with all of them can be part of the select statement. Clear? The select statement contains a lot of classes. Okay, so the first one, of course, select from. Okay, actually, you need only select to have a valid SQL query. But it's going to be weird, okay? Select, but I need, sometimes you can select one, select two, whatever, you can display that. But generally speaking, we have select X, project something from a relation. So we need to X at least one relation. So in most cases, that's what we need. We need to have a select from. But again, select by itself, the class, is valid SQL statement. So you can select, you can specify here distinct. What, like special keyword here? What do you mean by the distinct? This means I need to make sure that there is no duplicate for this tuple that we're going to be part of the result. So this remove the duplication. Okay. What else we have? So here they're going to be select the distinct. They say tuples using this operator or options. From is going to be tell me what's tables. Going to be asked. I'm going to talk about the alias later. Okay, you can specify or give a name for the attribute. Okay, sorry, the tuple that you work with. Where clause, we talk about just filter out maybe some tools that we're looking for. Not all of them will be part of the result. What else? We can use a group by. I can, or they say, organize the data, or they say group the tuples into subgroups using group by clause, which can be used later when you talk about the aggregation function. Remember relational algebra, when you talk about, we covered the aggregate function, we said we need to go by sometimes, it depends, in the command or the query that we need to retrieve. And by the way, if you understand the relational algebra, then this one can be straightforward. Of course, not exactly, but at least the same structure. There is no need to, you're not going to waste your time to understand how could you answer the query. The only thing that you need to do is how could you write your query using SQL. By the way, if you know how to write your query using relational algebra, the only thing you need to do is just direct translation most of the case. Okay, we do have something else. We're going to cover this one later. We talk about the having, which allow me in order to filter the groups. Okay, after you group the data, for example, you said, let's say, assume that you group the data and you need to compute, let's say, the maximum salary or the average salary per department for the instructor. So you get a department name, for example, the result, and this is the average salary. Okay, it's going to be computer size, whatever. Let's say 5 million or 50, whatever. Math, poor people, 10,000, and etc. Then you need, after perform the aggregation, you need to perform like having. You need to make sure the one that's going to be part of the result is the group, the one that satisfies this condition. So it will be similar to the where, but this one is going to be executed, as you're going to see later, after you perform the aggregation function. Okay? You can sort your data in ascending order, descending order. You can specify, fetch, say, a number of tuples. I need to fetch, for example, the first one, let's say the first, last one, and etc. So there are many options. Maybe I'm not going to cover all of them, but the most important thing, you're going to take a look, select from, where, group by, having, and order by. Okay? Let's go deeper and go with more details. But at least I give you like a general form of the select. What kind of select statement? What it looks like? Why it's very important? Because most of the things we're going to perform here, select somehow. Okay? So let's start with the first one. Assume that you want to, as I said, select it from where. So select is going to be, let me write this one first using the relational algebra. In the relational algebra, you're going to perform what here? You're going to perform, you have to ask the relation R1, R2. You can do this one, Rn, M, yeah? Then after that, you're going to perform what after that? You have a selection, the predicate. Then after that, projection based A1 up to A. Ready? Please? Clear, I mean? I don't know where early. Yeah, it's early. Clear? So this is a relational algebra. I know use a different expression. I use expression tree here. Okay? So that equivalent in this one. So select it from where? Here I need to show you one interesting thing here. What's the order of execution or evaluation? If you so select it from where, the system start execute evaluate this one from where. Whether it's going to be start with the select or from or where. If you understand the relational algebra, you can tell exactly how the system is going to start evaluate the system. The first thing you're going to do what? This is the order of evaluation. Always start with the from. In this case, I will start with the from. This number one. Ask the relation, whatever the set of relations, that's what you do here. Ask them before the Cartesian product. Then the next step here, after that, you do perform the where clause. So that's what you do, selection here, right? Then after that, the third step, you're going to see select. It's just project, I mean, the set of attributes that you're looking for or that you want to be part of the result. Clear? This is the order of evaluation is very important. Because later we're going to use some alias for the select. For example, let's do this one. Select, let's say A1 as, let's say, X from R where X is greater than 5. If you do something like this, and the relation R contains, for example, attribute A, B, C. Based on the order of execution, the system is going to do what? It's going to ask the relation R first. The relation R contains A, B, C attributes. Then, after that, you're going to perform the where clause. So the system is going to R, then after that select, let's say, X greater than 5. Do you have x greater than 5? No, but you said but the x is represent the attribute a, for example. But since I'm not gonna reach this one until I finish the from on the where, the system gonna get an error. Okay? So in this case, make sure that whatever you define here is not being available to the where class because of the order of evaluation. So from first, then after that do the where, then after that go to the select in order to project the list of attributes that we're looking for. Okay? So let's by the way, what the result of the SQL query? It's gonna be a relation. Okay? So let's have an example here. So find the names of all instructors. Okay, you need one. Let's do this one in the relational algebra. In the relational algebra, you're gonna do what? You're gonna instructor. Then after that, you're gonna be project name. Right? So in this case, this is gonna be from, and this is gonna be select. So your command is gonna be select name, because they ask me the name from what table is one to instruct one table, which makes sense to me. Clear? This is the way how to access one. And again, either gonna be uppercase, lowercase is case insensitive. Yeah, but in order to be safe side, try to use the same case that you use when you define the data definition language for this relation of this table or this schema for this relation. Okay, of the same. If you select uppercase, it's fine. Lowercase is fine. Mix them is fine. Either gonna be the uppercase or lowercase, it's fine. Okay? Either gonna by the way, some people are gonna say, can you do this one? Select name from, let's say, instructor. Yes, but here if you have more than a class, maybe it's gonna be confused a little bit. But it's the same. There's no problem. This one is equivalent. Feel free to go write the command in one line or different line or multiple lines. Okay? So let's have some examples here. Then after that, we gotta take a rest, okay, for 15 minutes. So the main difference here, we talked with the relational algebra, we said that based on the set, there is no duplicate. Okay, here, yes, is a multi-set or multi-sets. That means the duplication is okay in the relational data. I will say in the SQL or the relational data model in general. Okay, there's one one constraint that we need to relax here. So duplication is okay, is acceptable in the data. For example, I need to list all the list of the department for every single student that enrolled in this class. So maybe we have that all the students belong to the same department, which is computer science. So in this case, if we have say 15 students, so the result is going to be produced what 15 tuple, each of them have the same value. So repeated value is fine, unless you said I don't want them. So your choice. So you have full control. So in order to make sure that, or force the elimination of duplication, the SQL allows you keyword distinct or option, which we can add this one to the select in order to prevent the duplication of the value. Assume the instructor, for example, has, by the way, assume that instructor table, and you have ID. I want to show the department. For example, 1, 2, 3, 4, 5. Okay, computer science, math. Okay, so if I say this command like this, okay, this command, how many? What the result gonna be here after I apply this one over this instance? It's gonna be what? Computer science. Let's say, sorry, math. Of course, you're gonna see the department name, and this is the table that we have. Yeah. So the duplicate is gonna be there. It's not gonna be eliminated. If I said select distinct, so in this case, the difference is gonna be what? The value must be unique. So if you have a more than one value for the computer science, only list one of them. So the result in this case is going to be department name, because I said select the department distinct, and here computer science and math. You see that? So in this case we have only two. If I use distinct, so I'm going to enforce to eliminate the, let's say, the duplicate value. Clear? So One interesting thing, what if I wanted to select every single or all the attributes? For example, in the relation R that contains A, B, C attributes, I wanted to select all the attributes. I can say select A, B, C from R. Yeah? Or we can do the same thing. I'm going to say select star from R. So star denotes with asterisk. I'm going to do what? All the attributes that stored or that can be resulted from class. So either is fine. You see that either you specify every single attribute, or you're going to say star. Star, that means every single attribute resulted from this class. Because might be this class is going to have more than attribute from R. Maybe R joined with S, T, or whatever, that'll produce maybe a large number of attributes. Okay? Another thing, as you mentioned before, the valid, let's say the shortest valid SQL query is that the one that contains select only, without for. I can say select, for example, X. The result gonna be whatever column. Because I don't need the name of this one, then it gonna be has one tuple, it gonna contains one value X. If I say select one, the result gonna be the same thing, but here it's gonna be 1. Okay? If I said, for example, select 437 as foo, the result gonna be foo. This is the column name, and we have only one tuple contains 437. So it looks like you said burnt out. Okay? What if I said select A from the instructor? So in this case, it's just let's say RES. So it's gonna be RES with the result, with the name, whatever attribute that's specified. Because when you talk about the A as, that means it looks like rename this attribute. The outcome of this attribute, the name temporary is going to have this name. Okay? It looks like renaming the output. Because when you run this one, if you didn't specify, for example, what the attribute name here, if it's not exists, especially there is no form, so the system is going to come up with something weird. That's what we're doing in the Postgres. And unpredictable, what the name of attribute can be displayed in the result. So it might be between the question mark, you're going to write column, for example. Okay? In order to avoid that, I said, I name this one as RES, so the attribute is going to be RES. So here I'm going to repeat or display A many times. How many times here? It depends on the number of tuples in the instructor. If the tuple has 15 instructor, so it's going to be, displayed 50 times. Why you need this one? Maybe it's going to come to handy later when you try to, for example, insert data that, for example, 50 column that contains specific value. I want to join or union, let's say, with the existing data or add it to another data. That's one way to use that. Okay? So let me take this slide, then after that we can stop here. So one thing we can add is a selected class in general. We can do the generalization or generalized object or projection. We talked about this one before. We talked about the relational algebra. We said that one extension, we can do the relational algebra. We can, let's say, perform some operation, mathematical operation expression on the attributes that we have. You can multiply, you can perform division, you can add number, you can whatever. So assume the data here that we have ID name for the instructor, of course. We do have a salary, and the salary is annual salary. And I want to display the salary as what is called, let's say, the monthly salary. So how can you do that? Take the ID, name, salary, divide by 12 from the instructor. Yeah? And the name here, you can call this one as, let's say, monthly salary. You can give the name. So we can use as in order to rename this attribute, whatever the name of attribute in this case, because what it's going to be depends on the database management system that you're going to use. Some of them are going to use something like this column. I don't know what the value is going to be displayed here. So they're going to be ID, going to be name, and this one is going to be something column. So instead you have something weird. So I'm going to say I want to display the monthly salary as a temporary name for the attribute when you display the result. Okay? Okay, right back. Now let's take a look to the where class with more details. So where, that's based in this case, looks like you have like, not every single tuple is going to be part of the result. Only the one that satisfies the condition that we're going to write in the as a predicate for this within the where class. Okay. So for example, let's say if you want to find all the instructors in the computer science department. So again, it's similar to the relational algebra. The relational algebra, first you have to go to the instructor. Then after that, you have to perform the selection with the department equal computer science. Then after that, perform the projection when you're going to project the name. And the same thing that we did. We said select the name from the instructor where the department name is equal computer science. Okay? And the same structure that we did in the relation algebra, you need to figure out to take a look at the schema first. Then after that, by looking at the schema for the database in general, you can specify how many attributes or where the attribute that you're looking for belongs to which relation, whether you're going to access one relation or more than one relation. Okay? So, we can use the same thing that we did with the relational algebra, use the logical connectors. Okay, like and or. So you have multiple, maybe you have one predicate, let's say, so where the first predicate and, for example, the second predicate or second question, or the third or not, or whatever. Okay, you can combine all of them. Okay, so also we do have an operand. Right now, operand, like we did here on the equality, we're looking for the equality. You can express this one using the comparison, operators in this case. Less than or equal, greater than or equal, and etc. Or not equal to you, okay? So for example, I'm looking for all the structures in the computer science department. So it looks like computer science department with the salary greater than 80,000, so that we end here. So that's what we did. Select the name, since they name all the structure. Since they didn't specify what the name is, what they're looking for, you can say select a star, or if I maybe emphasize that I've said I wanna to list the names of all the instructor or name of all instructors. So in this case, you have to give me select. But in this case, since I said all instructor, you can use name, or maybe you can use a star. Either is fine, okay? From the instructor, with the department equal to computer science, and the salary is greater than 80,000, okay? And when you say and, what does that mean? For every single tuple here, you are going to perform the following. You check the condition here, or the first one, and this one, both of them must evaluate to the true in order this tuple is going to be part of the result, right? Or either of them. Okay. From a class here. So what we did so far, we just extract the data from one table. But generally speaking, you take a look at the form, you can perform this one, you can extract the data from more than one table. Okay? So you can say in this case, right now in this part of this chapter, we will only use the Cartesian product. The next chapter with the intermediate SQL, I'm going to show you how can you use the natural join or different join algorithm or join operator action. Okay? Quick reminder, Cartesian product that means concatenate two relations or tuple for two relations in one big relation, right? For every single tuple of the first relation, concatenated with every single tuple relation or the second relation. Yeah? So if you have n tuple relation R, m tuple relation R, S, that means we end up, we have n multiply m tuples, yeah, in total. And the schema for every single tuple, or the result relation, is going to be the tuple that belongs to relation R plus the tuple relation S. Okay? So let's see how can I do the Cartesian product with the instructor and the teacher. Remember, for the instructor and the teacher, let me go over this one a little bit here. The instructor is going to be ID, name, department name, and salary. Teach is going to be ID, course ID, section ID, semester and year. When you perform Cartesian product, that means for every single tuple of relation R here, it's going to be what? Join with every single tuple of relation teach. Alright? So as a result, you see that we have the same two columns in the results relation. And that we have the same name. So in this case, we have to find a way in order to distinguish between them. In this case, we're going to use the relation name as a prefix, okay, for the common attribute that is going to be part of the result. So you're going to be instructor ID dot ID, and here we're going to use the teach ID dot ID in order to distinguish between them. Of course, as we said last time, or before we talk about the Cartesian product, when we use this one in the relational algebra, we've said, see, this one I'm going to generate is too much information. Okay. In other words, there's many tuples are not correct. So in this case, it's going to join whatever or show us some instructor with the course they never teach or never taught before. Yeah. So if you take a look here for this instructor here, example, this guy teaches the course taught by another instructor. So there's something wrong here in this case. As we did before with the relational algebra, when you use a Cartesian product, you have to follow this one with the selection. Filter out uncommon attribute, or make sure that only keep the attribute that have the instructor ID is equal the teacher ID. And that's what we did here. Okay? So, for example, find the names of all the instructors who have taught, to say, some course. Okay? And also you need the course ID. Or you need the course ID, name of the instructor. I can get the information of the instructor. The course ID, I can get the name of this information of the teach, but I need to join both of them in order to figure out the list of the course taught by specific or particular or every single instructor. In order to perform this one, Cartesian product. So this one, the first one here. Then after that, too, it's going to be filter out unwanted tuples based on the common attributes with instructor ID is equal teacher ID. Then the third part is going to do what? Just project the name and the course ID. Okay? And this is the result, looks like something like this. What if I said, just I need to add something else? I need only names of the instructor, all the instructors in the computer science department who have taught some courses, say, and the course ID. So it will be the same thing that we did before on the previous slide. The only difference here, I need only the instructor that belongs to a specific department. So in this case, you need to do this, add this. Make sure which one the department name is going to be part of the result. Take a look here. Actually, do you need both of them here? Let's go back here. You just to make sure the department name equal computer science. So in this case, there is no need to specify the department name belongs to which relation, because it's clear that based on the context that we have, and the system can tell for sure 100% what department name attribute you're looking for, the one that belongs to the instructor. If we have department name, maybe have attributes going to be listed in both relations. So in this case, we have to add, we have to use the prefix here. So in this case, there is no need to use this. I'll just give you an example. You can use it, but there is no need because the system can tell exactly the department name that belongs only from the instructor relation in this case. But if in the case of ID equal ID, I have to specify which ID I mean. The ID that belongs to the relation instructor must equal the ID that belongs to the teacher relation. So in this case, I have to specify the prefix. Okay. So again, this one, either this one here or remove this one, either is fine here. Good. Now let's take a look to the rename operation in general here. So generally speaking, we can rename the name of attributes. We can give a temporary name for the relations, and etc. So let's take a look at the simple thinking. Generally speaking, I'm going to use old name as a new name. That's the meaning that we can perform here. So the first thing here, let's give you an example. If I give an alias name for the attributes. If I say select, let's say salary divided by 12. Let's say the ID and the salary divided by 12 from instructor. Okay, give me a second. So what we have done now, select the ID salary divided by 12 from the instructor. When you display this one, I want to give another name, temporary name for the salary divided by 12. So in this case, I can use something like this as, and say average salary, something like this. You can give temporary name. We call this one alias name. Okay. So when you print this one, that's going to be displayed the ID and it's going to be the average salary. Another thing, we can use an alias here to do what? In order to give, let's say, a temporary name to the relation. So sometimes you try to access the same relation twice in order to achieve the data, or join or concatenate the data belongs to this relation in order to figure out, to find out or figure out your solution, or require to access the relation twice. So how can you distinguish between the attribute that belongs to this relation and the other relation? The prefix as the name of the relation doesn't work in this case because both of them gotta have the same name. Yeah, you can rename them, or you can use or give an alias to this relation. So that's what we're gonna do here. So here is that find the name of their own instructor, okay, who have higher salary than some instructor in the computer science department. So in this case, I'm gonna do what? I need to find the name, okay, from the instructor, and I'm going to ask the instructor, two copies from the instructor. When I say ST, so in this case, I'm gonna give an alias. So it looks like we have two temporary relations. We have a T, which is gonna have a copy of the instructor, one copy, and another copy is called S. There are two separate copies of the relation instructor. Okay, so either I'm gonna say st or without s. The system gonna say, yeah, I know that's you're gonna use an alias with a temporary name for this relation, only during the execution. Then after that, it's gonna be done. Okay, so we have two copies. So I need to find a reason in order to find all the tuples. Okay, the name of all the instructors who they have like higher salary than an instructor of computer science department. So I'm gonna go to the other relation, either TOS or AOB, whatever name you're gonna use. Okay, try to use the name of attributes. I mean, is not used as an attribute name, as an alias is not used as an attribute name. So in this case, go to the relation S. Oh, now I have S. I need just to filter out all the tuples that satisfy the condition computer science department. Can I do this one? Yes. So in other words, you join T and S. You get a big relation. T Cartesian producted S. If you saw a single tuple here, you're gonna join with every single tuple S. Then, in this case, you need to make sure that only the department.name. So now we're gonna make sure the department that belongs to this tuple here, or this relation, is equal to computer science. So that's what I said. I said s.department name. Why I did this one? Because now in the Cartesian product relation, we have department name attribute that belongs to this relation, and we have another department name attribute that belongs to other relation. Okay. What else? After I do that, I need to make sure the salary that belongs to the column T. So I have to say T the salary must be greater than the salary after satisfy the condition that belongs to the computer science department. If you found anyone is greater than any of these existing salary of the computer science department, then this one will be part of the result. Clear? Kind of? Okay. How can you handle with the string, work with the string operation here? In the string operation, that means you're gonna try to compare with the string, okay? Right now, by the way, in SQL Standard, the quality operation in, let's say, on a string is case sensitive. What does that mean here? If you try to compare hello with hello, the system is gonna say this is false. Why? Because here hello is uppercase and this is lowercase. Even one letter. Because the case sensitive during comparing the attributes or the data stored within the attributes. This is single quote, that means it's like a string. Okay? But if I ask you, or suppose that you wanted to find, say, an instructor or a student, you don't remember his or her name exactly, but maybe you remember that I think the student name start with letter A, B, but I don't remember the rest. Something like this. How could you search? In order to perform that, we're going to use what is called, the like pattern. Okay, so we're going to use like expression or pattern expression. We can use this one in order to tell the system, in order to specify the condition that I'm looking for. I'm looking for example, the student, they start, or his or her name start with letter A and B, and this I'm not sure. Or maybe you're going to say, I'm looking for something, a title of the course that contains database somewhere, but maybe in the beginning, maybe in the middle, maybe in the end. So this kind of questions that occur that you can use the like in order to find out or figure out whether the data exists or not. Okay, so the symbol, if you're looking for a student that contains this one, the simple thing I'm going to say, okay, select name, let's say from student, okay, I'm going to say where, I'm going to say name, like. Do you remember the first letters? And the rest I don't know? Yes. Okay, like, and then say the first one letter A, the second letter B, the rest I am not sure. That's why I put this one A, B, and use a percent. Percent that means in this case it like matches any tuple or any string that exists in any tuple that contains 0, 1, 2, or any number of let's say strings. So in this case, the system is going to check if I found name start with AB, only it's going to be part of the result. If AB and maybe one extra letter, I don't know what's X, whatever, it's going to be part of the result. Anything AB, 2 extra letters is going to be part of the result. And that's it. Okay? So it makes our life easier. Okay, in order to find out to search for the whatever I'm looking for. Okay? So that's what's called, I construct pattern here with a string attribute student name or whatever name, like a pattern here. I construct this one by combining, you say, the literal value, the same thing that we did with the wildcard character. And we're going to use the like, okay, in order to find a match to this pattern, okay? So, by the way, in the general, the standard, the SQL standard, to provide us with like what? With two different or two wildcards. The first one, %, that means match 0 or any, and the underscore, which exactly match a single character. Okay, for example, I'm looking for, let's say, student that has name, but I'm not sure the exact name of the student, but I remember the first name for the student maybe contains exactly 3 characters. I don't know what the exact 3 characters, but I know that's exactly 3 characters. Or let's say the title that has only 3 characters, something like this. You can say this increment select whatever you want from whatever relation where, let's say, the title, like, since you know exactly 3 characters, 1, 2, 3. So in this case, this is the pattern that I construct. And the system gonna try to figure out if any match or any match of this pattern. So that means if I found any title or any tuple in the relation R, where the column title or the comment or the value of the title of this tuple contains exactly 3 characters, so this one gonna be part of the result. You can mix them, you can combine them. What if you're looking for the title that contains, say, database, but I'm not sure. Might be in the beginning, might be in the end, might be in the middle, whatever. So you can say here in this case, like, okay? And the title, I don't know the beginning, but it contains database, for example, and the end. Okay? So the system gonna see if any title, for example, in your data, that at the beginning has database, then whatever might be 0 or more character, or maybe there is a leading character 0 or more, as long as we have a substring database that be somewhere, and the end might be 0 or more character. So you have a full control about how could you search your data. Okay, we do have something else. It's called don't like or not like. What if you're looking for someone it's not like? You're looking or try to search for data that doesn't like contains, let's say, this pattern. Okay, so in this case you can use instead like. I'm gonna use not like. So I have another option here we call not like. Okay, either you're gonna use like or not like. It's gonna be the same structure. Like do what is called case sensitive. So if you said, for example, I'm looking for DB, or let's say something like this. I want to have a simple thing here. What if I said I'm looking at the title like the database, whatever. So if the data stored somehow in the title, assume that relation R that contains title and other information, okay? So title, if the title have something like database 1 or whatever. So this one is not going to be part of the result. Why? Because they are not matching. For the like, it's going to say the first letter is D, this lowercase, this uppercase, so this one is not going to be part of the result. Although it contains database, DB, that's what I'm looking for. Okay, this one match, this one okay, because they have DB and any 0 or more character at the end. Since it's case sensitive, the database management systems have different ways in order to handle this one. For example, for the MySQL and I think Postgres, they have I like. Yeah, I think MySQL is not case sensitive; it's case insensitive. Okay, but in this case, when you work with the Postgres, you can use I like. Yeah, so I like this means in this case is similar to the like, but we don't care. It's gonna be case insensitive here. So if you use I like here, so the system is gonna say, yeah, this one is gonna be part of the result, and this one is one. Why? I didn't care about the different case here for the letters. Okay. And this is just give you an example. Here I'm looking for the oldest name of the instructor. They include the substring or specific name. Might be the beginning, might be the end, might where. That's what I'm looking for. What if you have tried to find the string that contains, let's say, percent as a part of the data or value of this attribute? So in this case, you have to use escape. Yeah, so you can say like 100 escape. So the system gonna say here, yeah, you're looking for something that contains this value. I'm not gonna treat this one as a wildcard because we use escape. Okay. So this is just examples. Just to show you us like how can you use that. For example, into percent. That percentage in this case we have the character that start with 4 letters, INTRO. Okay. Here that contains COMB. Somewhere as a substring as the either beginning, middle, at the end. Here exact match contains 3 letters or 3 characters. Here, if match any string or that's what we're looking for of at least that contains how many characters? 3, because 1, 2, 3. When I say at least, that means this one must be filled with 3 data, and this one can be 0 or more. Might be 3, might be 4, might be 5, 6. It depends now on the percentage. Another thing, we can use a concatenate operator here. Assume that we have a relation, example, which contains first name, last name, for example, an ID. For example, ID 1, Alice, Brown, Chu, Bob, Red. Okay? And we'll update it. Then I wanted to display what? I want to display the last name. I want something like this. I need to have a Brown, comma, Alice, and display as a name. 1 and 2, I want from you to display something like Red, the last name, comma, the first name. How can you do that? So I'm going to show you the way how to perform that. So in this case, I'm going to say select. Okay, from what? Just say I need to select something special. I need to select the ID, okay, first. Then after that, I need the last name, comma the first name. How can you do that? I'm gonna say the last name. Let's say so. Yeah, last name. Okay. Then after that, I'm gonna use the concatenate here. That means you can use command operand. I'm gonna use different color. 2 vertical lines. Okay. That means last name, this one is gonna be, it looks like you are going to create string. It looks like you take the first part of string here, add whatever you're gonna type in. I need to have a comma, yeah? So I can have comma between single quote. Then after that, concatenate with what? With the last, the first name, yeah? We call this one first name. All this one gonna be named as a name because I want to name the attributes as a name, okay? From where? From the relation R. Okay, so in this case, take the first tuple, this ID, take the last name. This one is gonna be one attribute, and this attribute is gonna be has a 1 column, and the name of column is gonna be name. Take the last name, gonna be here Brown. Then add this one, concatenate this one with a comma, because I use this command. Okay. Then after that, concatenate whatever you had the first name, which is gonna be Alice. So that allows me to print 1, Brown and Alice. Of course, it's the ID, and here the second column is gonna be the name. So this is the way how can we use, or perform some operation with the string. There is another functions that we can use them. One of them allow you, for example, to convert whatever the content of the attribute to the uppercase. All of them are gonna be uppercase, or it's gonna be lowercase. Yeah. For example, if the same data that we have, I want, for example, the last name is gonna be uppercase and the first name is gonna be lowercase. Okay, so I can use this one here. So select. I'm gonna say the ID, comma, let's say we said the first name is gonna be lower. Okay, I'm gonna use lower, and here between 2 parentheses, I'm gonna say first name, comma. The last name we said is gonna be upper, so it's gonna be upper. This is a function I add and suggest or include the attribute as a parameter argument from the relation R. So this one is gonna do, for example, take the first column or row by row. For every tuple or row that we have, let's say the first name is gonna be lower name or lowercase, all the letters, and the last name is going to be all the letters going to be uppercase. So in this case, it's going to be 1 as a result. ID. And here, of course, you need to specify the name of the attribute is going to be displayed. Otherwise, it depends on the system. Some of them maybe going to be, say, lower between 2 parentheses, and some are going to put something weird, and they say column between 2 question marks. So assume that whatever the attribute here, and whatever that's the third one, so the ID one, the first lower is going to be pound. So Alice, lowercase, and the last name is going to be pound, something like this. Hopefully it's clear. Hopefully it's not messy. When I say messy, I'm not talking about the Messi, Barcelona. Okay. So, what if I want to sort my data? Oh, no, you sort your data. You have to add another command. It's called order. By the way, the order of the class is very important. So you cannot, for example, put the order by before from, or put select at the end. No. Must be have the specific structure. Select from, where, or, and, etc. Okay, you cannot change the order of the classes that we have. So back to the slide. What if I wanted to sort my data based on the name or whatever? I'm gonna use order by. Okay, so order by here in this case, you have to tell me exactly based on what attribute you want to perform. So let me first show you the evaluation. How can we, the SQL standard, going to evaluate this command in this case, or this clause in the statement? First, starting from. Then after that, this is the funny thing. You have to do select too. Then at the end, you do it's going to be order by. The order of evaluation of these clauses is very important. Clear? So I'm going to do from first. Then after that, do select, whatever you have commands here. Then after that, do the order by. So the order by is going to be the last one. Clear? So let's do this one. So we're going to X the instructor. For every single tuple, you're going to distinct the instructor name. Maybe you have a duplicate name of the instructor. Once you display, so here you have a name. And here we have a list of all the instructors. This is the result here from the step 2. Then after that, I'm going to sort them. And you can specify when you say order by the name, which attribute name. You can specify ascending. That means you're going to perform this one, let's say, in ascending order. Or you can say, I'm going to do this one in the descending order. But by default, it's going to be in ascending order. So the smallest value is going to be at the beginning, and the highest value is going to be at the end. In the descending order, that means in reverse. The highest value is going to be first, and the lowest value is going to be the end. Okay? Let me play around a little bit here. So, what if I said the length of the name? Okay, the length of the name. Let's say distinct. Okay, here's this one. This is interesting, by the way. I like this one. Distinct length. This is another function, another method, which allows me to count the number of characters stored in this attribute. Okay, and I said as L. Can you use as L? Yeah. From the instructor, order by L. Can I do that? In other words, this one, okay, you can't do this function, by the way. Just compute this one, and compute is going to be, for every single name that we have, it's going to be compute the number of characters. Since we have a distinct, that means we don't have a duplicate value. Okay? I give an alias with this attribute, or this whatever, it's going to be a result in this operation, or this expression. I call this one L. Then after that, I'm going to say use the value that's stored here, compute it here. Of course, this one is only for temporary, okay? Use. After you run this code, done. Yeah, so I'm not going to change or modify the content of the relation, only during the runtime. Okay, when you say order by L, can I use whatever an alias that I define and select here in the order by or not? Can I use this one here? After I define this one here? And the answer is going to be yes. Why? Because what we're going to do here, first, the evaluation order is going to be start with a from. So you're going to access the instructor. Then, 2, you're going to execute the select. When you execute the select, now you're going to extract to compute the length, name, based on every single tuple in the relation. Then after that, we're gonna create this one or put the result or rename or let's say store this information under the column called L. Now L is available because now you execute select. So after this step, you can use L as a normal attribute. Okay, which is said order by the L. That's why this is okay. Okay. You can order by, let's say, descending order. Here, by default, it's gonna be, let's say, ascending order. There's no need to write ASC, but if you want to make sure that, I mean, the descending order, that means you have to tell the system that the order by the name or by L, for example, in descending order. So the highest value is going to be in the top and the smallest value is going to be in the lower. Okay. You can order by two different attributes. For example, I can say order by the department name, but after that the name. So the data will be sorted by the department name. Assume computer science first. Then after that math, for example. And after that physics. Okay, and etc. Then within each department, you're gonna store this one based on the name. And you can specify, for example, I want the department name in the ascending order. I need the name in the descending order. Yes, you can do this one. But remember, this one is going to be for, it looks like you have subgroups. For the computer science, based on department name, then after that, based on the name. Yeah, within each department. Clear? So you have full control. You can select data. You can specify specific predicate. How can you extract the data that you're looking for? Then after that, we show you how can you perform, let's say, extract the data more than one relation. How can you give alias to the relation? Then after that, to the attribute, okay, or to say to any expression. Then after that, I show you how can you perform some operation of the string. Then we look at the way that how can we order the displaying the tuple or result in the final result and mean here during the execution time. I'm not gonna sort the data in the lower level. This is just what I'm gonna see here. Okay. Another thing here, for example, what if I wanna to find the data that between two levels or between two values, okay? Or a range of values. For example, I'm looking for, let's say, the student, they have the GPA between 2.00 and 3.00, for example. So you have a range of the data, or here as an example, find the names of the instructors with the salary between 90,000 and 100,000, okay? So it looks like in this case, do what? You're gonna take the salary. Yeah. This is similar. This is the way how to perform that. I'm gonna say select the name from the instructor where the salary less than or equal 100,000 and at the same time the salary is greater than or equal 90,000. Okay? We can write this one using between, and between has a special structure. So in this case, we're gonna say we have a value, whatever the salary is gonna be between. And this case is going to be between, let's say, the low value and the high value. So you have to tell me, for example, what, let me write this one. The command, between and. So you have to tell me the value, whatever the attribute that we have, between what's the smallest value and what's the highest value. Okay? You have to specify them. So this and this are the commands. Or they say belongs to the where class, okay? Or you can use this one. So either way are fine in order to find the value that you're looking for. What if I'm looking for the salary that not between, let's say, 90,000 and 100,000? You can use this one differently. You can rewrite your command or this query here in order to figure out the way how can you find the value is not in this range. Or the simple thing I can use what? Not between. So in this case, I'm gonna do the following. I can say salary not between 90,000 and 10,000, 100,000. Yeah. Okay. You can compare, let's say, multiple values at the same time. We call this one the tuple comparison here. For example, I need to make, in this case, generally speaking, how can we write this one? You're gonna where the instructor ID equals, say, teachers ID, and let's say the department name equal biology. Okay, so that's what we perform here. So this is equivalent to this one. So since I'm going to compare instructor with the teach and department with the biology, the third attribute with the third value attribute, so here you can write this one as following, or you can write this one. If you wrote this one in this way, given in this slide, we call this one the tuple comparison. Okay? Makes sense, hopefully? So far, so good? Remember we talked about the set operation here before in the relational algebra. So we're going to see how can we perform union, how can we perform, let's say, intersection, and how can we perform, let's say, set difference. Okay? We're going to see how can we perform that using the SQL here. So union is what? Union, as you know before, is combines the tuples, or let's say sets of two or more, let's say, relation, or select. So it looks like you have one select, another select, and the third select. You can union all of them. So more than one, let's say two or more select. So you have one select statement, that's the meaning here. And it's going to be combined with another select. It might be another, you have union with the third one, union with the fourth one. Okay? So you have a select something, union, another select. Okay? So in this case, I need just to find the courses that ran, let's say, in the fall 2017 or in the spring 2018. So the first select is going to display the list of the courses that taught or ran in this period. Then after that, we have another select where they find all the courses in the spring 2018. Okay. Then after that, I'm going to do union here. So write this one. By the way, this one, there is no need to write this one. I put just parentheses here just to show you that this is one select and this is another select. Clear? Must be between two select statements. And the result can be single result. Of course, in order to combine them, we do have some conditions. The same that condition that we use when we define that, or let's say set operation using the relation algebra. The number of the columns in both relations must be matched. For example, you cannot say select course ID, comma name, union select only course ID. We have two attributes in the first one, and you have to say one attribute in the second select. No, remember we talk about the union compatibility? The exact thing that we talk about here. Okay, and those the same number of attributes, and the attribute must have, let's say, what is called the same data type. Okay, or the data types must be compatible. For example, don't say, for example, assume attribute A and B. Attribute A is the integer, for example. Attribute B is char. It does make sense. Okay, the same thing what you're gonna do with the, let's say, intersection. Okay, so in this case, like union operators, the intersect operator combines what? The result sets from where? Two different selects or more, two or more actually, might be more. Might be you have intersect with the third and etc. Okay, so the first one select here. For example, it all display all the costs that, for example, for around, let's say, or total in fall 2017. Okay. And I need the cost that in the spring 2018. So this one is going to be, the first one is going to be fall 2019, and the second one is going to be spring 2018. Then I'm going to do intersect. That means the costs that run here and there. Okay? And the same thing must be the same condition that we have as the case with the union. One more thing I need to add when you talk about the set operation here, I need to make sure that we don't have a duplicate data. If you have a duplicate tuples, it's not going to be part of the result. The system automatically going to ignore them because it's a set operation. But if you want to keep them, if you want to keep the duplicate value after you perform union, I'm going to use union all. Okay, intersect space all. Okay, and the same thing when you talk about this one, it's going to be all here. Okay, union all, intersect all, except all. That means I'm going to keep or force the system, please, if you have a duplicate value, keep them. Don't remove them. Okay, to retain all the let's say duplicate attributes. I mean tuples, sorry, duplicate tuples. What about the set differences? We don't have minus here. We do have except. Yeah, for the SQL, that's one difference here. I cannot say minus. I cannot use that minus command. I can use only except. Okay, except. So in this case, it's gonna do what? Find all the courses, for example, that for 2017, but not in spring 2018. So the first one is gonna display the set here. Select one, all the courses for 2017. The second one, I'm gonna produce or try to figure out all the courses spring 2018. Then I'm gonna say whatever you have here and not here. So that's what I'm gonna use except. Okay, that's the set differences between them. So return here the tuples by comparing the result sets of 2 or more queries. Okay, and in this case, it's gonna only return the distinct tuples from the first one, or the first select, okay, that are not in the second select. And that's the except. Clear? And as I mentioned, if you want to keep the duplicate value, you can use union all, intersect all, or except all. Caution. Okay, how can I handle the null value? Oh, null value is just, it's headache, okay? But sometimes we need to have this null value somehow in our data, okay? So the null value means that the value for this attribute, for this tuple, this attribute, it's not given, is unknown, okay? Or doesn't exist. I don't know what the value is going to be stored here. So the simple thing, we're going to put this one as a null value, okay? So when you perform any arithmetic expression that involves null value, for example, somehow you're gonna say, assume that you're gonna get 5 plus the attribute x, and the value of attribute x at this column, or this attribute, or this to say at this tuple is null. So we end up we have 5 plus null. Okay, so the result is gonna be here what? It's gonna be null. So any if null, it's going to be involved in any arithmetic expression. The result is going to be null. Clear? We need to use this one later. Good. We do have this like special operation or operand, or to say option, or to say predicate. It's called is null. What does that mean here? This one is going to help me in order to decide, in order to figure out, to find out which the tuple has null value or not. That's the meaning here. Okay, or actually the attribute that contains null value or not. For example, I need to find the list of all the instructors whose salary is null. And sometimes when you start entering your data, maybe you didn't have all the information. So for example, at that time, we didn't have the salary for some instructor. So what we're gonna do, we're gonna insert this one them as a null value, or we don't give that value. Now we need to update my data, we need to change. So we need to come up with the list instructor. They don't have the salary, but the salary is null. In order to do this one, I can say select name from the instructor, where the salary, I'm going to use a special, let's say, predicate is called is null. So this one is enough by itself. I check the value of the salary for every single tuple. For every single tuple, if the value is null for the salary, the stored inside the salary attribute, then it's going to be, this tuple is going to be part of the result. Okay? There is another thing is called, predicate is called is not null. So in this case, we can tell you or come up with a list of the instructor whose salary is not null. So I can instead use is null. I'm going to use is not null. Okay. I know we have too much thing we covered today, but I'm going. I encourage you to go over this one again. Try to do this one by hand. Okay. Try to practice. And don't worry, we do have at least 2 or 3 homeworks. Actually, gonna be 3. Just gonna cover, the SQL, because I wanted from you to make sure the most important thing for me in this class, you understand how to design the database, which cover the class projects, phase 1 and 2, plus how you work with the SQL. Okay? And how to access the data using, let's say, external programming language, which is the one that we cover using the phase 3 of the class project. Okay, so let me go back a little bit here, just to remind you here. We said that the result of any arithmetic expression involving null is null. 5 plus null multiplied null is going to be null. Okay, good. The SQL is going to treat as unknown the result of any comparison involving a null value. So for example, if you said an attribute less than, greater than another attribute, the system, if you found something like this, someone is going to say from where the null value came here. Because you're going to say, for example, x less than y. And for this tuple, where maybe the value of x is going to be numeric value, whatever, and the value y of this tuple is going to be null value. So in this case, we end up, we have this situation. So the system going to treat this unknown value as what? I mean, treats as a null the result of any comparison involving null value. Okay? Of course, I'm not talking about is null is, or is not null, a different story. Those are going to have a special treatment. So in this case, this one is going to be evaluated to the unknown. And that's it. Okay? So now, sometimes a predicate we do have what? We do have, like in the where class, maybe you have a Boolean operation. For example, you have something y and z greater than 3 and something like this. Or maybe it can be or, maybe it can be not. Yeah? So we have a Boolean operation here. So we need to extend the definition of Boolean operation in order to handle another factor or another value is called unknown. In the Boolean, let's say, when you work with the truth table in general, we try to figure out the Boolean expression result for any expression, or any given Boolean expression. You need to do what? You need to handle the truth, let's say, and, or, and not, right? Now, for the and, not, and or, and not, we do have only two possible values. Either it can be true or false, right? For every single, let's say, value that we need to evaluate. Here, every single value, it might be true, it might be false, it might be unknown. From where unknown came, when we have like any predicate that contains, let's say, comparison that contains involving, let's say, a null value. So how can he handle this one? So I'm going to go over this one a little bit to see how can we handle this situation by adding or treating, let's say, or modifying the Boolean operation in order to do what? In order to deal with the unknown value. Just give an extension, okay? So anyway, for the end, assume that somehow you said, for example, x greater than y, and we have expression, and let's say have two expressions. Okay, this one is going to be evaluated to the true. This one is going to be unknown. Why? Because this one is going to involve, let's say, something with null value. We say 3 less than null. So in this case, what we have true and unknown. What you have to do? So I'm just modifying my truth table. True with unknown can be definitely evaluated to the unknown. Okay? False with the unknown, that means might be this one false. With unknown can be evaluated to the false. Definitely unknown. Because for the end you have both, the input must be, or value must be true. You don't have true. If one of them is false, definitely, false, definitely, regardless whatever the value of the operand, the result is going to be false. Unknown with unknown, if both of them here unknown and unknown, the result is going to be unknown. Okay. For the or, the same thing, the situation. Assume that we have an or here. If you have an or here, so in this case, it depends whatever the value that's for each operand, right? It might be unknown or true. Unknown or true in this case is going to be evaluated as true because the true table, I know that for the or, one of them is true. This means the result is going to be true regardless of the value of other operand, okay? Or the evaluation of the other operand. In this case, or the second option, unknown or false, they'll be unknown because I don't know. Unknown with unknown, they'll be unknown. Then, not of unknown, and going to be unknown. Sometimes you said not, or use not, and in this case you have 5 greater than null. So the system is going to say not unknown here. So this one is going to be evaluated to the unknown. So now we end up with the where clause, something like we have either it's going to be true, either going to be false, either going to be unknown, right? At the end, we have only one final result here. So the system or the SQL standard set or states that if the where clause has unknown value or evaluate a unknown value for the specific tuple, we treat this one as a false and ignore. This one is not going to be part of the result. Thanks for that. Clear? Good. We are going to take a look to the aggregate function. We covered this one before, right? So what do you mean by the aggregate function? The aggregate function is a set of functions, okay, that perform a calculation on the set of tuples and return a single tuple, right? you can compute the maximum, you can compute the minimum, you can compute the average, you can count the number of tools that you have. You can compute the sum. Okay? So we covered this one in the relational algebra, but here I didn't show you how can you use this one or do this one using the SQL Standard. So the average, I can compute the average for all the values. The minimum, I can compute the minimum for all the values. The maximum to the maximum value. The sum only total. That's means I expect the value can be numeric value only. Okay? I need to compute the count. I give you two options. One of them I can use the count star. The second one you can count based on specific attributes. They say ID or name or whatever. Okay? What is the difference between them? The first count star, that means just count the number of tuples that we have in the table. If we have a tuple that contains null value, in this case the system is going to treat this one as a tuple. So I'm going to include even the value is going to be null value. So all the aggregate function that we're going to show you here, with except the count star, when they found the values null value, they're going to exclude this one from the computation. It looks like, oh, it's no, I'm not going to include this one. I'm not going to count this tuple. Okay? I will go over this one later in more details. The count of the attribute, you can specify specific attributes. So for example, assume a relation R that has A, B, C, 1, 2, 3, 1, A, let's say 2, 3, 5, whatever. Okay, data. Then I need to count based on the attribute A. And this is useful here, because in this case, if one of the value of the attribute A, for example, equal null, assume that we have A1, 5, 6 here, and here the value for this, the third one, we assume that we have only 4 tuples, okay? And this value is going to be null for A. If we said count based on the A here, in this case, the system is going to say only the values 1, 2, 3. It's going to exclude the null value. So that's useful. When you count based on specific attributes, you can specify, for example, whether the value is going to be distinct or not. Ignore the only count the number of unique value, or you can specify that or state that in case we say count the attribute name. You can tell the system that please, if you found any automatically actually, if you found any null value that's stored in any tuple for this specific attribute, ignore this one. It's not going to be part of the computation. But for the count star, I don't care. It gives you the total number of tuples that's stored in this relation. Okay? Of course, if we make the group by group, we use the group, or say organize the data, or to break the data in subgroups, it's going to count the total number for each group or bare group. Okay? The sum and average, of course, require numeric input, because they need to sum what? It needs some the salary, some. I'm not going to sum the names. I'm not going to sum string values. Yeah, and the average too here. Good. So when before give you the count ID and distinct ID, assume that we have a relation, simple relation R. Okay. And this simple relation R is going to contain, you say, the ID and name. Okay. Maybe the IDs were not a good example. Let's say department. I assume the ID 1, 2, 3, computer science, math. Okay? If I set count, to say department, what's happening? What's the result going to be here? The system is going to ask here, assume this is the data that we have, count based on the department name. 1, 2, 3. The result is going to be 3 here. Okay? What if I set distinct here and I say based on the department name? The system is going to say, remember, when we say count distinct, that means if you have a duplicate value, eliminate this one. So in this case, they're going to say, this is the first unique value found computer science, 1. What is this? Computer science, I already count this one, so I'm not going to count it again. Math, 2. So result in this case is going to be 2. So if you use it, this is the benefit using the count based on the specific attributes. The system can allow you in order to specify whether you're going to include a duplicate value or not in this operation that you're going to perform. Clear? Hopefully. Good. Let's have some examples. Assume that you want to find the average salary of the instructor in the computer science department. Okay, I need the average salary from the instructor where the department equal computer science. So you're going to eliminate all the departments. So the way that access one again, one from, two where, three select. Okay, this is the order of evaluation. And the result in this case is going to be what? The average salary. Okay, or it might be something like column. It depends on the database used, whatever the name of attributes. Then here we're going to compute what's the average salary. It gives you only one total, right? Which contains only one value. Compute the average salary based on the computer science department. Clear? The other thing, we can find the total number of instructors who teach a course in the spring 2018 semester. Okay. The condition acts as teach, because it's the teach, the relation that contains all the information about the courses that are taught by every single instructor, and include the time or the period when they teach every single course. And here just say the semester equals spring and year 2018. So there is no need to group this one, right? Because it is filter out only the two will satisfy this condition. Then after that, so when you perform the execution or evaluation one, act the teach, then two, you're gonna funny as two. Anyway, so you're gonna access this filter out all the tuple that does satisfy this condition. So all the tuple must be semester spring and year 2018. Then after that, I need to count the number of distinct ID here. And the question here, why I said distinct ID? Because I need just to find the number of instructor. And there is a chance there is instructor maybe going to teach many courses at the same time of this period. For example, you've said spring 2018, and I taught with 3 courses at the time. So do you going to count me 3 times or count me only 1 time? So you see the difference here? Yes, I want to count you only 1 time. It's enough. I know there is an instructor teacher course at the time. Regardless, on the one hand, I didn't say I want to know the number of courses teach by every single instructor. No, I said only the number of instructors who teach a course in the spring or any course in the spring. So if any instructor teach more than 1 course, it must be counted only 1 time. So that's why I need to have a distinction. And again, you can use I encourage you, advise you to rename the value of attribute here that you're going to be, or the name of the attribute actually. Maybe you're going to say, for example, instructor count. So when you run this one, you're going to have like instructor count. And here's going to be, for example, 50 or 100 or whatever the value here. Okay? If you want to find the number of tuples, the cost relation, so the only thing you say count star. Why use a star? If they have any tuple has null value, it will be include part of the result. Okay? Or you can use the count course ID, because we believe that we don't have any tuple is going to be blank or all of them are going to be null, because we enforce that in this case. Remember, we have a course. The course is going to have the course ID. The course ID is a primary key. So it's not allowed to have a tuple that contains the primary key. It's going to be null value, right? So in this case, either going to count star, or you can use count, let's say, the course ID in this case, right? Who's going to give me the same result. Clear? Okay. Let me go over this one. Then after that, let me go the grouping here, because since I'm starting about the aggregate, let's go over this one a little bit. Then after that, let's go for the short tutorial just to show you how to download the data. Prepare your database or download the Postgres in your computer. Then after that, you can start working in the lab or practice at least. We talk about the grouping, okay? And the grouping allows us in order to what? In order to group the data, okay? All right? And generally speaking, most of the time, you're going to perform the aggregate function with what? Based on the set of groups, okay? So we need to find a way which allow us in order to divide the result set into set of groups, of tuples, of course. And I'm going to apply the aggregate function on each group, okay? With minimum, maximum, whatever. So let's do that. In this case, I need to use what is called the group by the way. So let me first remind you what we did in the relational algebra. This is the way the aggregate function, right? And here you specify the list of the groups that you wanted to break data or divide the data result set into or based on. And here, the list of the aggregate function that you need to perform based on each group or subgroup that you define. All right? This is the corresponding or equivalent command, or if you want to use this one, use the SQL here. So in this case, I'm going to say select the list of the groups. It's going to be part of the result. Remember, when you define or create a group, it's a good idea the group is going to be that used in order to divide the data and going to be part of the result. Because if you said you're going to select or say display the average salary for the instructor per department. If you have 5 departments and the result is going to be have 5 average salaries, if you didn't include the department name as a part of the result, so I cannot tell which the average salary belongs to what department, because you're going to have maybe 5 different tuples. Okay, so there's a good idea to have the aggregate, they say the group by attributes is going to be part of the result if you want. Then after that, it makes sense most of the time. Then after that, you list the aggregate function. Okay, from might be more than one relation. I tried just to simulate this one. Okay, then after that, we're going to use predicate if we have. It depends if you want. The most important thing, since we use aggregate function, most of the time you're going to use the group by, which is going to be based on the list of it. Maybe, for example, I'm going to divide my data group by or split the data based on the department name. Okay. So grouping attributes are specified in both the select clause and the group by clause. Here must be. Here it depends. And most of the case we need them because it's going to help me in order to understand the result that I have. One thing I need to go over this one. So what's the order of evaluation in this case? Which was interesting here. When you have a select from where group, almost the first one from. Good. Then after that, in this case, where. Good. Then after that, we have this interesting thing. The group by. Then after that, number 3 is going to be the group by. Then after that, based on what I have, number 4 is going to be the select. So here I'm going to perform, let's say, the aggregate function. Oh, actually, when you perform the group by, you're going to perform the aggregate function. Okay? So the order is going to be from where, then after that, group by, then after that, the last one is going to be the select. Okay? Good. So assume that, yeah, this is the same one. By the way, you can do whatever you want here, yeah? You can, I know this weird command. I don't know why I keep this one here. This just show you that you can perform minimum A plus B minus maximum. You can perform any arithmetic operation if you want. Yeah? And the group by, you can, for example, perform expression that has multiplication divided by a specific value if you want to do that. Maybe very uncommon, but still also valid. Maybe not, we never use a command like this, but it's still valid based on the rules that we have. Let's do this one. Again, I give you the order of the evaluation. And we said in this case, just I want to perform this one again and again. The first one is going to be the from, the second one where, the third one the group, the fourth one the select. Okay? So in this case, if I have a condition in the where clause, do you think the condition in the where clause can be evaluated based on the aggregate function or not? The condition or the predicate in the where clause can be used in order to evaluate or filter out whatever result set that we got or received after we perform the aggregate function or not? What do you think? Based on the order of evaluation, not. Why? Because I'm going to do perform, then after that perform where, so I'm going to execute or evaluate whatever the condition that you have in the predicate in the where clause, then I'm going to perform the aggregate function. So whatever, so where clause, constraint, the set of tuples that grouping and aggregate are applied to, but it's not going to perform, let's say, help me after I compute the aggregate function to do anything else. Okay, let's have the example here. Assume that I wanted to find the average salary of the instructor in each department or per department. So in this case, you need to divide your data based on the department, group by. Then after that, you need to perform the aggregate function. And that's what we did here. We said here select department name and the average salary, and they like to use different name in order to have the name of the attribute from the instructor. And they said here group by based on the department name. So the system gonna first go to from. There is no where. Then the second one is gonna group. I'm gonna divide my data here based on the department. Then now start with the select. And when you talk about this one, group by, now starting evaluate the average salary, etc. So for each of them, it's gonna compute the average salary. Okay. Then after that, it's gonna display the department and the average salary. So the average salary here, the average salary here per group. And here it makes sense to add the group name or the attribute that you used for the group by. If you didn't include that, see that's what's gonna happen. This is the result that you're gonna have. Can you understand what do you mean here, the average salary? We have many values, but I don't know which one that belongs to what. So here in this case, it makes sense to add what the attribute name that you use in order to group by as a part of the result, because this one is gonna help me in order to understand the result that you have. Okay? I will go over this last slide, then after that I'm gonna stop and try to go with the short tutorial, okay? So anyway, so what if you have this command? It said select department name, ID, average salary from the instructor, where or group by the department name. So here you get the data. Let's see, I mean the ID, I just add the ID here. Just I add the ID here. So the ID, comma here. You divide your data here, okay? Based on each department. Then now you need to compute the average salary. Then now you need to display what? You need the department name. You need to have the ID. Let me put the ID here because I don't have space here for each department. The problem here, if you add something in the select and you didn't specify this attribute in the group by, the system is going to be confused here. I'm going to say, okay, it's not allowed in this case. Why? Because in this case, each instructor we do have, like here, okay, in particular group has what here? It's gonna have like divided by department name can have different ID, right? And this is the same thing here. You see that for every single instructor, which ID need to include here? If I include the ID here, which one I need to compute with the building? Which ID you gonna choose with the biology? Which ID you gonna use with the computer science? So we have three. Which one? There is no unique value. So in this case, it's not going to be works, okay? Unless you put the ID here as a part of the result. So in this case, the system is going to say here, add the ID, and it's going to repeat the value of ID for every single one here. It's going to be part of the result. So anyway, if you try to do something like this, this is just allowed by the SQL, because there is no unique way of choosing which ID value is going to be output here, okay? So I will stop here for the class. So next lecture, we're going to start with, continue to talk about the aggregate function.